Welcome back. So let's continue. And I want to repeat that you can ask all the questions you want. You can ask them on Zoom just in written. And even if you're in the lecture hall and you don't dare to raise your hand, you can also write it in the Zoom chat. That's absolutely fine. And we've seen people do this in the past. It can be a little less scary. So where was I? Yes, all the operators that we first did on sets of bags, and now we are doing it on sorry, not sets of bags, what am I saying? Sets of maps. And now we are doing them on bags of maps. And we already saw how the union, the intersection, and the subtraction of tables leads to specific behavior. For union, m plus n. For intersection, mean of m and n. And for subtraction, it's the max of 0, m minus n, which essentially means m minus n, but taking 0 if it's negative. You see that it's asymmetric, right? Because subtraction doesn't commute, as you might remember. Okay. What about projection? Well, that's an easy one, because projecting a bags of maps to specific attributes just is the same thing as on sets. You just don't bother to eliminate any duplicates, right? If you just retain exactly the same number of maps. It makes it different in behavior because in bags of maps semantics, when you project, the number of records, the number of maps remains the same, always. You remember that for sets of maps, the number of records in the projection might be less. Who remembers that? Right? Because since you need to eliminate duplicates, projecting with the set semantics might produce duplicates that need to be removed. And so the projection might be smaller in terms of the number of records. But in terms of bags of maps, in the bags of maps semantics, the vanilla flavor of the relational model, we always have the same number of records in a projection. Selection is also very easy, right? You select bags of maps in exactly the same way you select on sets of maps. It works the same. And even on sets, the selection wasn't producing duplicates anyway, so it also will not add more duplicates. It's only taking some of the maps that satisfy it. Who finds it easy? Projection, selection, you already agree it doesn't make a difference? For bags, who agrees? Right, okay, it's intuitive. So that's the easy part. There's not a big difference. Renaming an attribute is the same. There's also no big deal of difference between sets or bags if you rename an attribute. Renaming a relation, totally trivial. You just change its name to S. Now, the Cartesian products. Can anybody tell me if I do the Cartesian product of bags of maps and I have for a specific pair of values, in that case, bar2 false, and in the other table, foo1, and I have R times the first value on the left and S times the first value, S times the second value on the right, how many times will I have it in the Cartesian product with the bags of maps semantics? Any guess? On Zoom, maybe? Do we have any answers? If I give you a bag with 5 apples and another bag with 10 apples, and I tell you, give me all the possible combinations you can find of these apples, how many will there be? All pairs of apples that you could take from these bags. Yes? Exactly, S times R, that's it. So in that case, you would have 2. If you had twice the same value and 3 times the other value on the other side, that's 2 times 3, right? We just take all possible combinations of the physical records like this. So then we have a duplicate R times S times. Who agrees with this? For whom is that intuitive? Yes? Okay. We have a new operator, delta, that we did not have on the sets of maps because it was totally useless. That's the duplicate eliminator, right? It's like Sarah Connor, you've been duplicate eliminated, right? So delta. So we just remove the number of duplicates. We just bringing it down to just one. So it means that if you apply delta to bags of maps, you will always get a set of maps. For whom is that clear? Right? Delta on a set would be the identity. Delta wouldn't modify anything if it's already a set. Okay, so that's a cool new operator, and we'll see we have that in SQL. We also have the SQL syntax that allows us to do this. So again, I insist on chocolate, vanilla, strawberry. We have these three flavors. I didn't do it on lists, but you can also do the same. You just preserve the order in a way that's meaningful for the operators. Note that for Cartesian products, you might have more than one way that is meaningful, right? There's many ways you could order the Cartesian product, but this is minor. It's just a matter of preference or a matter of implementation. Okay, so we're actually done. So by the way, on lists, you do have one more thing you cannot do on sets or bags, that's sorting. If you have the lists of maps semantic, then you also have operators that sort the records according to a specific criteria, right? Okay. Now, I see that today there's a bit less question, and I have the feeling, so it can be because of three reasons. The first reason is you're bored because this is so easy and I'm just too slow, or you're completely lost and you don't understand anything because I'm just going too fast, or it's just Friday morning and we are soon switching to winter time and you're tired. And so the best way to know is to ask you, just so that you are aware that you can control my speed. So in the middle, you're tired. On the left, I'm just too slow and I'm boring you. And on the right, you might be a bit lost because I'm going a bit fast. So it's a tie, looks like. More people are just a bit tired. Yeah. Right. So what I read from this is the speed is okay-ish, but maybe a tad bit fast for some of you, right? So I just need to be very careful that at least I don't accelerate. Maybe I slow down just a little bit. We still have a majority of people for whom the speed is al dente. Okay, very good. So nobody is completely lost, at least less than half, so some between 50 and 79. So first, what I have to say to reassure you, do not worry, because that was a highly theoretical part, right? It's a lot of math, and not everybody has a mathematical background, right? There might be mathematicians, physicists, there are other departments with a less formal background, so it's totally okay. The next thing I want to say is you will have the exercises to practice. So probably it's not this week yet, right? The relational algebra, that would be next week, right? So always with a bit of an offset to let you digest a bit. You should read the book, the chapters of the book that are, you know, how to access the PDF in the library of ETH. And if after reading the book, solving the exercises, you have the feeling anything is not clear, drop me an email, drop an email to the TAs, write on the Moodle forum to interact. We are here for you and to guarantee that you're learning, that we clarify anything that is unclear, right? So never hesitate to ask a question. I know you're not computer scientists, right? So I know you have different backgrounds, and so there is absolutely no such thing as a stupid question. Okay, so now that we have these statistics, I'm going to stop the recording.